Good morning, students. Today I will explain you frustrum of a right circular cone. First question is that what is frustrum of right circular cone? Listen, if A, B, C is a cone and when it is cut from any point parallel to the base, suppose A, B, C cut by D which is parallel to the BC and AD is removed, then you will get DECB, which is a portion left after removing the ADE. This portion left is known as the frustum. Okay. Again listen, if a one portion of the cone is cut from a point which is parallel to the base. So after removing the portion cut ADE, we get DECB, that is the left portion of the cone ABC, that is known as the frustum. Now we have to explain height, radius and the slant height. See, in the case of the A, B, C, if the total height AM is h1 and the OM is small h, then the height of the AO, that will be equal to h1 minus h. So h1 is the height of the cone, small h is the height of the frustum, then height of the AO is equal to h1 minus h. Now in A, B, C cone, if L1 is the slant height of the ABC and small m BB is the slant height of the frustum and MC if the radius of the base of the ABC R1 and R2 is the radius of the upper part of the frustum, that is MC is R1 and the OE is R2. Now you see A and C, that is a right angle triangle. So A and C and the AOE, they are similar triangles. By 2A property, if we take A as a common, then the angle AOE and angle AMC, they are equal, the right angle triangle. So we will say AOE and the AMC, they are similar triangles. So AM upon AO, that is the ratio of the height, is equal to MC upon OE is equal to AC upon AE. So by similar triangle property, now AM upon AO, that is H1 upon H1 minus H, and MC is R1, O is R2, is equal to slant height L1 upon L1 minus L. So taking the ratio of the height and the radius, if we write this h1 upon h1 minus H is equal to R1 upon R2, we may write it H1 minus H upon R1, H1 is equal to R2 upon R1, and if we simplify this equation, then height of the frustum is equal to R1 minus R2 upon R1 into H1. That is, height of frustum is equal to R1 minus R2 upon R1 into H1. So, this is the height of the frustum. Now, let us surface area of the frustum, that is pi R1 plus R2 into slide height, that is pi bracket R1 plus R2 into slide height, that is slide height of the frustum. Then the total surface area of the frustum is, that is lattice surface area plus area of the base ring plus area of the upper ring, that is pi R1 square plus pi R2 square. So the total surface area of frustum is pi bracket R1 plus R2 into slide height plus pi R1 square plus pi R square. Then come to the volume of the frustum. You see, volume of the cone is 1 upon 3 pi R square H. Now here it is part of the cone, so that is 1 upon 3 pi H, and this R1, R2 and R1 into R2. So 1 upon 3 pi H bracket R1 square plus R2 square plus R1 into R2. This is the volume of the frustum. So again listen, what is frustum? If from a right circular cone a portion is cut from the top, then the remaining portion, that is known as the frustum. And these are the formulas, that is height of the frustum, lattice surface area, total surface area and the volume of the frustum. And these formulas, they are derived from the two similar triangles, that is AOE and the AMC. These are the similar triangles and the ratio of the sides is equal. So I think it is clear to you what is frustum. If you like my video, please share and subscribe. Now in my next video I will explain you by taking some examples how to calculate the height of the frustum, lattice surface area, total surface area and the volume. Okay, thanks very much.